Welcome everyone. Thank you for making it to the next video. So this is the first video now where we're going to be going through the first lesson. So hopefully if you've had a chance to complete this lesson, that'd be great. But yeah, let's get into it. So this first lesson is called Making the Zombie Factory. Okay, so these whole set of lessons are going to be kind of based around the idea of releasing our own NFT collection with these zombies. So almost imagine if you were making a zombie NFT generated 10,000 collection. This is a tutorial which is going to explain a lot of those ideas, but it gives us an overview of a lot of Solidity concepts. So let's take a look. So the first page, this first chapter, just more of an overview really. What it's mainly showing us is we've got these different genes here. So these are different like traits that we could use to generate random NFTs for our collection. So we could randomly generate different values here and be able to create a different zombie. Okay, so that's kind of what we're showing here on these sliders, what we're able to do. So contracts. So as I said in the previous lesson, contracts the main building block that we're going to be working with. Okay, everything that we develop, all of our clever functions and things that we build are going to be within inside a contract. So to create a contract, it's fairly straightforward. Okay, they give you an example here. Okay, so what it's saying is this first part is asking us to, firstly, what we need to do is we just need to put in the version of Solidity we're using here. So the top line of all our Solidity code is always going to be this pragma Solidity, which just tells it that we're using Solidity, and then we just need to define a version. So here it's saying that we want to give version 0.5.0 to 0.6.0, and then at the end just add a semicolon. That just ends the line, that terminates the line. Okay, and then below here is saying create a new contract. So we say contract, we're going to call our contract zombie factory, and we're going to open these parentheses like so. So these are just used to say everything within our contract is going to be between these two curly brackets. Okay, and I think that's the first lesson. Okay, done. Excellent. So we've created a contract. We've said what version of Solidity, we've created a contract. Okay, so the next part is state variables and integers. Okay, so what is a variable? Okay, well, a variable is kind of, you can think of it as just a placeholder that we're going to store some information in. Okay, so here, this is a variable. So this variable is called my unsigned integer, and they said that this is equal to 100. I could do the same. I could have my fave number, for example, is equal to 10, for example. Now you might be asking, what's this part here? All this part is, before we give the name, is this is the data type that we're going to be using. Okay, so there's different data types. We could have string, which is basically just like a word. So like my word equals, say, hello. We could have an integer, which just basically just means a whole number. And we could again have that as number 2. And we could have that set that equal to 5. But basically this unsigned part, this is just another data type, and it gives an explanation here. The uint data type is an unsigned integer, meaning its value is non-negative, so it can't be 0, and it's whole numbers basically. So what things could we give this data type? Sort of 0, 1, 2, 3, 4, 5, whole numbers that are bigger than 0. But don't worry about this too much right now. Okay, so we're going to create a variable here, what it's asking us to do. So it's going to be of type uint, it's going to be called DNA digits, and it's going to be equal to 16. Okay, perfect. So math operations, okay, so like many programming languages, we can do different math operations in Solidity. So if we wanted to add two numbers together, we could by just using this plus. If we wanted to subtract, we could use this minus. Multiplication, use this star. Okay, so as you can see here, this is an operator which is sort of to the power 2. So here we could say that our value of x, our variable called x, is going to be equal to 5 to the power of 2, which is 25. So these are just math operations that we can do in Solidity. Okay, so what it's asking us to do is we're going to create a uint called DNA modulus, and we're going to set that equal to 10 to the power of DNA digits. And don't forget a semicolon at the end. Perfect. The reason we don't need a semicolon on the contract part is this is, we're not sort of terminate the line. We'll keep everything within here is live, but then when we do each little part here, each statement, we have to just put a semicolon just to terminate it. Okay, so our next lesson is on structs or structures. So basically these are another kind of data type. Don't get too confused over these, but basically, so it's asking us here to create a structure called zombie. Okay, so they've created a structure called person. We're going to create a structure called zombie. So struct zombie. Okay, I'm going to open these parentheses again. Now with structures, what we can do is we can give certain attributes or members to this zombie. Okay, so what we can do, it's asking us here to give it two properties. So the first property is going to be a string called name, and the second one is going to be an unsigned integer called DNA. And what that basically is doing, we're setting up here so we can create zombies in the future which have a name and a DNA associated with them. Okay, so we could do something similar. We say we could have a structure. We could have a structure called cars, and we might want to have, say, a uint on its. You could have, say, a string on the model. You could have a uint on the tire pressure. You could have a uint on the cost of the car. You could have a uint on its value now. So these are all like different parameters that we'd associate with all cars that we can set and access basically. So this is us defining our zombie structure here. So next lesson is arrays. So we can think of arrays really as being sort of a big list. Like if you imagine you had like a big shopping list, that would be almost like a 1D array, like a one-dimensional array. You've got just a list of items going down in order, and if we wanted to, we could pick, say, the 10th element of our shopping list, or we could pick the 50th element, but that would be sort of an array. Another array, almost like the computer screen, the monitor that you're looking at now, that is almost a 2D grid. So it's a 2D array of pixels, okay? So you've got pixels going along the top, and you've got them going along the bottom, like vertical and horizontal. So that's giving you a 2D array. So let's have a look here. Don't worry about this too much. It's just saying we can, if we wanted to, we could say that our array is only ever going to be a length of 2. So if our shopping list had more than 2 things, that would be a problem if we said it's only going to be 2. But also we can set up an array to be of any size. So we could have an array of any size that's dynamic, where we could just keep adding to our shopping list forever and we wouldn't have any problems. Okay, so let's see what it's asking us to do. So basically it's asking us to create an array of structures really here. They've given us an example of how they've done it for people, but we've got to put it to the test now for zombies. Okay, so using their example, we're going to create a zombie. So this comes from, they had the person part here, the person structure. We've got a zombie structure. So we're creating a zombie array. So this is an array of these zombie objects. Okay, don't worry too much for now. And we just need to, what do we need to do? So because it's a public array, which these are basically just access. So if things are public, then it's accessible by more people or everyone, potentially, I assume. But we could probably set this to like private as well and things like that. I think there's some other ones as well. So we're going to create an array of zombie objects. We're going to say that it's public, and we are going to call it zombies. Okay. So for now, this is empty, but we've just sort of we've created it for now. But it's just not got any zombies in. We've said we've got an array of zombie objects, but there's no zombies in there right now. Okay. Don't worry too much if this is confusing. It's okay. Don't bear with. So we're going to check the answer. Perfect. And we're going to move on. So next we're going to talk about functions. Okay. So what are functions? Basically, a function is something that we can give a function something and it gives us something back. Okay. So here they've created an eat hamburgers function, and every time you want to run this function, basically you have to give it the name of the hamburger and the amount of hamburgers they assume you're going to eat, and it'll give us something back. So let's do a quick example. So say we have a function called, say, add numbers. We could give it number 1, and we could have number 2 here like this, and so this is saying here, so this will be the name of our function. This is, say, the 2 things that we're going to give it, and then maybe we want to equals number 1 plus number 2 and return value. So we could do something like this, whereby, so a function, if we were to create a function here called add numbers, this would be a function that every time we were to run it, say if we were to run add numbers and say 10 and 20, okay, then the value that we get back, okay, would be from running this function. So we could then run this function with whatever inputs we wanted. So we could code up a big long function, okay, and then each time we wanted to run it, so every time we wanted to add 2 numbers, we could just pass those numbers into the function without having to redo all this code. Okay, so that's a bit of an overview of what a function is in general. So what's it asking us to do here? Okay, so it's asking us to create a function called create zombie. So to do this, the first thing we're going to type is this function keyword. So we're creating functions, we're going to type function first. The next part is we're going to give it our name. So it's going to be create zombie. And then we need to give it what's it got to work with? What are its inputs? Okay, so its inputs are going to be it's going to be a string called name. It's going to be and a uint called DNA. Okay, and it's also asking us for the function to be public. Okay, so we've got to just say what is the level of access for this function. So for this one, the level of access is public. Okay, now I think, is that right? Oh, don't forget to pass the first argument by using the memory keyword. Okay, so this is a little caveat that you've got to remember, that basically when you are when you're using strings or arrays into functions, you've got to use this memory keyword just to store the data. So I believe that goes there. Let's check the answer. Perfect. Okay, we move on to the next chapter, which is working with structures and arrays now. Okay, so creating a new structure. So remember our person structure in the previous example. Okay, now we're going to learn how to create new persons, new people, and add them to our array. Okay, so this is how they've done it here. Okay, they've created a new person called Satoshi, and then they've given it the parameters that it needs for this name and this DNA. Okay, or age and name here. Okay, and then so once we've created it, what we want to do is we want to add our new person to a big long list of people. So by doing this push Satoshi, so we've created Satoshi here, new person, and by doing this push Satoshi, this is basically saying add that person, add Satoshi into our big long list of people, which is our people array here. Okay, so let's try that for ourselves. So this is asking us to, so first we're going to create a zombie, and our zombie is going to be called Oh, okay. So we can do this all on one line. So we can combine these two lines into one line like I've done here, which means we don't really have to name what that particular zombie is. So let's try that. So if we have zombies, so this is going to be our empty array here. We're going to add on to it. So push. We're going to add on a new zombie. So we're going to do this zombie, which is going to allow us to use this structure here. And we need to give it the name and the DNA. Okay. So we're going to give it this name and this DNA from this create zombie function here, which is going to mean that when we run this create zombie and we give it what it needs, we give it its name and its DNA, then it's going to add that, it's going to create that zombie and it's going to add it to our big long list of zombies. Okay, so we have a constant tally of what zombies are created. Let's check this answer. Perfect. Okay, private and public functions. So we've touched on this a little bit, but what this is basically saying is how we talked about before. We've got this access modifier here. So we can change this depending on how we want to restrict this function. So by changing this, we change who is able to run this function under certain circumstances. You can imagine that being useful if you say only wanted the owner of a particular ENS domain name to be able to run a certain function. Okay. So let's put it to the test. So we're going to change this public to private. And that's correct. Okay, so we just missed something. Okay, so this doesn't matter too much, but it's convention to start private function names with an underscore. Okay, so convention just means it's the common thing to do. It's kind of good practice, but it won't make any difference whether you use an underscore or not. You can name things whatever you would like, but that is the convention that people stick to, so it's easier for everyone. So let's check that. Perfect. So this next chapter now is more on functions. Okay, so so we were talking about return values before, how we said we could create a function to add two numbers together and get it to return that value. So this is how we do this in Solidity. So it's showing us here, we've got this function called say hello, and this is our modifier, so we're saying whether it's public or not. And then this is how in Solidity we return something. So we say on this top line that we're going to return, in this case, it's going to be a string. Okay. And then here, return greeting. So that's the string that's being returned. So let's give it a try for ours. Oh, and it's also just saying here, there's two more modifiers here, view and pure. So you could add these in next to private. So to achieve, just to change the access, I believe. So it's saying, so in this case, we could declare a view function, which means it's only viewing the data but not modifying it. And we can also define a pure function, which means you're not even accessing any data on the app. So depending on what you want to achieve, you can use these different modifiers. But let's give it a try. So it's saying create a private function. So I'm going to call function. It's going to be called generate random DNA, and it's going to take one input, which is going to be a string. So we've got to use that memory keyword, and it's going to be called str. So we've got a string called str, which we're giving in, which we're inputting into this function, and then it's saying it's a private function. So for that keyword there, and it's also telling us in the next part it's a view type of function, and then are we returning anything? Which point should be empty at this point. Don't forget to set the location of the string. Okay. So these are parentheses that we're gonna write our things in our function. Don't believe we're returning anything on this one, so let's check the answer. Nope. So what have we missed? Oh, sorry, we're gonna return a uint. Okay, so this is where we put returns, And then the thing that we're going to return, we need to just open the brackets and say we're returning a uint, like so. Okay, so I believe that to be correct now. So this again is creating a function. This is what the function's called. This is what we're passing it, and it's of type string. It's a private function, which is going to return this uint value. So just a number, basically. And perfect. And then, so chapter 11. This is Catcher 256 and typecasting. I'm not actually too familiar with Catcher 256, and so if someone is, let me know in the comments. But what is typecasting? So basically, how we're talking about these different data types, we've got a string, we've got uint here. We could also say have int. So what if we've got things of different types? Say we wanted to add DNA and value together. Well, because these are different data types, then it's going to start complaining us basically that we're using two different data types. So one way we can get around this is by typecasting. And basically, what typecasting is we're setting we can change the data type essentially. We can cast to a certain data type. We can force something to be a different new data type. Okay, so we can see that here from this example where we've got a value C and we wanted to multiply it with this B value. So this here, this brackets around this uint8 open brackets is where we're casting this B value to this new data type. Okay, if that's a bit confusing, don't worry too much for now. Bear with us. But yeah, let's try this exercise. So the first line of code should take the catcher256 hash of abby.encode. Okay, so let's try this. Catcher256 abby.encode packed, and so it's going to take the string value. Okay, and then we're going to generate a pseudo-random hexadecimal, typecast it as a uint, and finally store the result in a uint called random. So if we're storing the result, we can write that to this side. So this is where we're storing the result. So we're creating a uint called random that's going to have where we're going to store our result, and that's going to be equal to this catcher256. And to typecast it, this is what we do. So to say we want the result of this to be a uint so that it matches, we can typecast like this. Okay, I believe this is to do with a hash function actually. So it takes, by giving this string input, we create a completely by changing the string input by say one value. So ENS trading post to ENS trading post exclamation mark would give completely different hash functions here. So I believe that's what this is doing at this part. Oh, forgot the semicolon at the end, don't forget that. Oh, have we done something wrong? Oh, forgot the second part. So then what we need to do is it's asking us, so the second line of code should return a value. So you see how we can, this returns uint, so we need to return. So we need to return, and the thing that we're going to return is our random value, and then this modulus sign of DNA modulus. So you might be thinking, post, what even is this modulus sign? If I can click on it here. But basically, all this is doing, it's just an operator. So like you've got a plus, minus in maths, this is just going to give us the remainder basically. But yeah, don't worry about this too much for now. It's just we're using it at the moment because we only want our DNA to be 16 digits long. So this is just something we're using to do that. So now, chapter 12 is we're going to be putting it together. So let's put some of those different parts together. Let's do this exercise together. So we're going to create a function. It's going to be called create random zombie. It's going to take in a string which we're going to save to memory called name, and that's all it's going to take in. And it doesn't seem like it's returning anything, so Oh, so it's a public function. And then we're going to open these parentheses for what we're going to put in our function. Okay, so the first line of the function should run the generate random DNA function. So do you remember how I was saying before, to run a function, we're basically going to type the function out like this, and then we're going to think, what do we need to give this function? Okay, so we can have a look here. So we've got this function, we need to give it a string. Okay, so we need to put a string value in here, and the string value we're going to put in is from this name value here. So we're going to put in name as our string value, and what we're going to do, and this is going to return us a result, so it's going to return us this. We need to save that somewhere, so we're going to store it in an unsigned integer called random DNA. And then perfect, the next line we are then going to run, after we've run that function, we're going to run the create zombie function. So we can have a look, what do we need to give it? Create zombie, we need to give it a name, and we need to give it a DNA. So we're going to give it this name from here, and we're going to give it this random DNA value here. Okay, perfect. Now let's check the answer. Excellent. Okay, chapter 13, we're getting there now, we're nearly finished, is events. Okay, so events are a way for our contract to communicate with something that's happening on your front end app. Okay, so if a button's pressed and you want it to call a certain function, if you've got a website and you've got a mint button or you've got a renew button or something like that, you can set up an event to listen for when that button's being pressed and then use that to do something within your smart contract code. Okay, so here they've declared an event called integers added, and then this here now, this is where they're firing that event. This is where that event will be used. So we have to declare the event first, and then we have to say in our code, we have to do the logic for when we want to fire, when we want that event to happen. Okay, so let's put it to the test in hours. So this is how they've done it here. So we're going to use those as an example. But it's saying create an event. So event first is a keyword. We're going to call it new zombie, and we are going to pass it a uint called zombie ID and a string. I'm not sure if we need that memory keyword, so we'll try it for now. Called name, and we need a uint called DNA, and semicolon at the end. And then to fire it, we need to, so what's it asking us to do next? Next, modify the create zombie function, which is here, to fire the new event. Okay, what's it saying here? You're going to need the zombies id.array.push returns a uint of the new length of the array. Since the first item has an index of 0, array.push -1 will be the index of the zombie we last added. So store the result of this -1 in a uint called id. Okay, right, so what that means is here we can, this applies, so what we're doing here, so we can use -1, which will get us the last zombie which we've added to this list, but -1's basically getting us the last zombie, and we're going to store that in an unsigned integer called id. And yeah, that's what we're going to do first. And now we need to fire this event here, so we are going to run emit to fire it. We're going to run the name, so it's going to be new zombie, which is the event that we're firing. And now we need to give it these different things. So we need to give it an ID, a name, and a DNA. So where are we getting the ID from? The ID is from here, we've just created. Okay, so this is the ID. The name is this underscore name, and the DNA is this underscore DNA. Okay, let's give that a check. Okay, so for events, you don't need to worry about that memory caveat for strings. You must just define it, just as is like this. Perfect. Now, chapter 14, web3.js. So this is saying, so now our Solidity contract is complete. Okay, so this is saying we need to write a front end which interacts with the contract. So I believe this JavaScript contract, this JavaScript code here is what we're seeing on this side. So if we type in a name here, say ENSTP, that generates us, we're creating a new zombie from our input of our name. And that's something we've actually seen from the code actually, because we've seen it here when we're creating a random zombie, all it's taking in is a name. So by changing the name, which would change then the ENSTP part, we're changing this generate random DNA, okay, which is changing the DNA of our zombie, okay. So by changing this name value here, we're changing this hash function of this random part, which means we get a new random DNA, which is leading to us creating a new zombie with a different DNA, which is what we see here when we type a different name in. We are getting a new zombie. So this is what we've coded for today, to be able to achieve this of generating random zombies based off different text input. And I believe that brings us to the end of this lesson. Yep, completion of lesson 1. So that's everything from today's video. If you've enjoyed it, let me know in the comments. If you're a beginner and you did find this useful, let me know. If you're an advanced Solidity developer and there's some tips and pointers or things where I should focus my research on more, let me know as well. And yeah, thank you everyone for joining. Hopefully see you in the next one.